Hello everyone, this is Ivan Ross. The lesson we're gonna teach you today is all about numerical integration. First, the trapezoidal rule. Next is the Simpson's one-third rule. Trapezoidal rule. It is the first of the Newton-Cotes closed integration formula. But first, what is Newton-Cotes integration formula? It is the most common numerical integration schemes. They are based on the strategy of replacing a complicated function or tabulated data with a approximating function that is easy to integrate. It has the Newton-Cotes integrative formula has types, but we classify it into two, the closed form and the open form. The closed form, in closed form, the data points at the beginning and the end of the limits of the integration are known, which means that the start and the end of the integration is known and the value is just finite or limited. Another is the open form. Have integration limits that extend beyond the range of the data. The answer in this open form can be finite because the limits of the data extends beyond the limit. Let's go back to our topic, the trapezoidal rule. As the name suggests, it uses the formula of a trapezoid and the method of it to get the integration of the function. In graphing the trapezoidal rule, it shows us this. Unlike the usual trapezoid that has the two bases and a height, the height serves as the base and the width serves as the height, which means that the trapezoid is in sideways. The original function is this, but we use a trapezoid to get the suitable function of it. The function for the formula in this rule follow as this: I equals to integration of p and a f sub p times fb minus f function of a b minus a times b minus a it shows that it is the function, the formula seems similar to the Newton divided difference integration formula. But if we simplify further, the formula will be b sub a times f function of a plus function of b over 2. And we can find the width or height in trapezoid as b minus a over n, which we can use at the other method later. Next is the multiple application, trapezoidal rule. In this time, we divide the trapezoid into equal number of trapezoids and getting the function of each, then adding them together to get the suitable answer. It follows the equation like this. The formula will be b sub a times function of x sub o or b, but this time we can use x sub o plus 2 summation of f x sub 1 plus f sub o sub n over 2n. In finding the approximate error, relative error, b sub b minus 1, b minus a cubed over 12n squared times the second derivative of the function. This time we will use this formula h equals to b minus a over n. To know better, let's make an example. Evaluate this integral. In this given, the b is the pi over 2 and a will be 0. First, we get the function of pi over 2 and 0. Also will be 11.9985 and 12. Then we substitute into the formula b minus a, which means that pi over 2 minus 0 times 12 is the function of 0, but plus 11.9985 over 2. The answer will be 18.8483. The true value of this equation is 18.48488. If we get the true relative error, it will be 0.0025%. Next, we use the multiple trapezoidal rule. The given in the equation is same as follow. b equals pi over 2 equals 0. But this time, we must find the height or the width. b minus a over n. In this given, n is equals to 4. b minus a equal over n, pi over 2 minus 0 over 4, each will be pi over 8. Then we substitute, we get the function of the 0, pi over 8, and pi over 2. 12, 11.99999, and 11.9986. Then we substitute into the formula. I equals to pi over 2 minus 0. 12 plus 2 times the height, 11.999 plus 11.9986 over 4. 2 and 8, I mean 8. Because 2 times n equals 8. The answer will be 18.8488. If we get the approximate relative error, which means that pi over 2 cube over 12 times 4 squared times the function of the given, which is the formula will be this. Approximate relative error equals to negative 1 over 12 times the second derivative, which means 4 cos x dx. We must get the function, the integration of the second derivative, which means negative 4 cos x dx over pi over 2. Then we substitute to the formula, negative 11 1 over 12 times negative 3.994 times pi over 2 cube. The answer will be negative 3. The answer will be negative 0.0548. Then we first substitute to the formula, the first formula, the absolute relative error, the approximate relative error, 0.0548. The answer will be 0.0044. The true relative error will be 0% because 18.8488 is same as the true value, 18.8488. Simpson's rule. It is another closed form of the Newton codes integrative formulas. Simpson's rule is another way to obtain a more accurate estimate of an integral by using a higher order polynomial. If we graph this using f function of a and function of b, like in the trapezoidal rule. In the trapezoidal rule, we just connect the f sub a and f sub b and then make a trapezoid. But this time, we find another point at the middle of f sub a and f sub b, then connect to each other and get the higher order polynomial. For example, if there is one point between function of a and function of b, it can be connected with a parabola, which means a second order polynomial. If there are 2 points between function of a and function of b, it can be connected by a third-order polynomial. There are three types of the Simpson's rule. The Simpson's one-third rule, the multiple application Simpson's rule, and the Simpson's 3-3-8 rule. First, the Simpson's rule. It is the simplest form of the Simpson's rule because we find one-third of between the f sub a and f sub b and get the function of this point, then apply the formula. The formula in Simpson's one-third rule is this: b minus a times fx sub o plus 4 times fx sub 1 plus fx sub 2 over 6. To get the true relative error, it will be negative b minus a raised to 5 over 2,880 times the fourth derivative of the given equation times this symbol. Next example, integration of pi over 2, 0, 8 plus 4 cosine x dx. b equals to pi over 2, a equal to 0. First, we must find the function of each. Function of 0 equals 12. Function of pi over 2 is 18.8488. Then we must find the interval by h equals b minus a over 2. And in this given equals to 2. So pi over 2 minus 0 over 2 equals to pi over 4. Then we get the function of pi over 4 as 11.9996. Then we substitute to the formula pi over 2 minus 0 plus 4, 11.9996 plus 11.99986 over 6. Remind that this formula is the Simpson's one-third rule. The answer will be 18.8488. If we get the true relative error, it will be 0.00015%. Next is the approximate relative error. Pi over 2 raised to 5. We disregard the 0 because it will not change the answer. Over 28880 times the fourth derivative of this function, which is negative 4 cosine x. Then applying the equation pi over 2 over 0 times over the integration of 4 cosine x over pi over 2, which is negative 3.9994. The answer will be 0.0133.